Alright, so a few days ago, started out with this little light sensor here. You can see it. Yep, it's my ESP32, and took a few tries. Couple things had to change, but I think it's finally time to finish up the work on this and get it to a real template of code. So, what happened? So, if we pull up Arduino, where did I put that? Where's the code? Okay, go to our Arduino, open up our code. It didn't open up. Do I have? Okay, now it's opening. Okay. So if you're looking at the code, there were a few problems. This is what we had on Monday, I think. Was it Monday or was it earlier than that? I don't remember. Either way, the challenge was that first of all, we have these write operations, and the only thing we're writing in these operations is the command, because these aren't actually compliant with the traditional SM bus spec, where you send the device address, register address, and data. You just send in the device address and the command. To do that, I implemented each of these as registers that have 0 bits of length. And that works for writing. However, it does have this weird side effect where the data ends up being this. It still exists because I didn't know how to handle it. I didn't expect that to happen. So it creates this empty data variable. Now, functionally, it works. In terms of the API, it's a little imperfect. You have this function here, and this looks good. It's not a generic function, but it does require you put this dummy variable in there. I need to get rid of that. The other weird thing, this is where I got stumped originally, was to read data. And there's the read operation here. Do this read correctly. Again, it's not actually, there's no registers in this model, so I had to comment out this line, and I shouldn't have commented it out. I had to modify the generated code, but this line cannot be in there. I have to find a way to read the data without actually going ahead and writing the register address. If I comment out this line, the whole thing works, which is fantastic. I just need to fix this one part, and I think it's not easy because it's a slightly different model than normal, but I think I spent some time on it, put together a lot of different ideas, and I have a good idea of how to accomplish this task. I'm going to go ahead and do it. I'm going to go get some water really fast, and then we will get into it, and hopefully by the end of the hour I will be finished with this task and I will go make some dinner. Alright. Water's going to taste like coffee. That's okay. It's actually not bad. Coffee water. It kind of tastes like coffee, which makes sense because coffee is coffee flavored water. At least with more coffee in it. Alright. I hate these ads.
It's sexier if it's trim.
Okay. So, how to do this? I'm going to create a top-level function called read. I'm going to call this read weight intensity from the device. Description. Alright, so if you haven't been following, what I have done is fixed a few of the issues around the spacing, around the write. Now you can write better length, and it just emits the data parameter. Stuff like that. The one thing I do need to do is this read. I'm writing in the wrong file. I made some docs improvements as well. With some stuff with the life cycle is a little better as well. Do I have a life cycle here? I'm gonna have to. Yeah. So I have now renamed this to life cycle. This to begin. And then there's end as well. Anyway, I go here, put read light intensity from device. Description. It's the same one. Yeah. Computed. Light intensity. Now, this is the part that's going to be kind of, I need to so I'm going to have to create, well, first a variable. Let's call this intensity. It's going to be a BH16. So the logic here, I need to do intensity is going to be equal to a raw read command, and I wrote down the I gotta do that at some point too. Oh, I'm down to 19 issues, which, I mean, I think a few weeks ago when I started these streams, it was around 40, so quite a bit of improvement. And I've actually added a few new issues as well, around new things I want to end up supporting at some point. These are what I actually wanted to tackle today. I took some whiteboarding stuff. Okay, so that's. I just want to do a raw read of. I think in the photo I said 2 because I'm referring to read 2 bytes. But I think I'm not going to do that. I think I'm going to put this in terms of bits, just to be safe. I think in this case it's 16 bytes. 16 bits, 2 bytes, full bytes, not something weird like a 9 or 12. But just to be thoughtful, I'm going to put that down as 2 bytes. No, 16 bits. 16 bits. I'm creating a new command in the sudo YAML, so I'm going to have to implement that across the various things, which I don't think will be that hard, but we'll have to see. So, there you go. And basically, I can just return intensity. Nope, I cannot. Can I? I think this will work. Yeah, it should work. Now let's start to implement this stuff. Arduino is probably the first one to do, just because we have it. But can I do it that way? Let me think about this a little bit. This design is okay, but how do I... key equals... But I want to use a key. Check if a read read up if key if okay if raw read in step key, then I want key to be equal to no, well, indirectly. Now, here is where I do not put right register address. So now let me open up the Arduino template here to scroll down up, in this case, to where we're doing our reads. So this is quite a bit of a extra code, but and then actually at some point we want to put bytes. Set bytes to step key raw read by 8 round, seal it off, and then it. But then it should make sure it sets the key correctly. So let's go ahead and I'm gonna hope this works. Let me do ESP32 and you can copy it over to our source on the other side really fast. So Python source code during T. Let's go ahead and clean and let's do a peripheral / BH1750FVI.yaml. Nope, unhashable type. Right, I'm actually pretty hungry. I want to put a break right there so that it exits out of the loop. Alright. Let's take a quick look at our read. Okay, we have to attribute int 8. Int 8. Alright, so we have our uint 8 t intensity. Here's our datum. We do a device address and transmission request, read intensity, return intensity. This will be the well, so let's go ahead and over to our left window. So we use a serial monitor. So we're seeing Lex is 5. That makes sense because it's pretty dim in here right now. Here's my phone. My phone out. Put on the flashlight and it's now going up, and then I move the flashlight away and it goes back to normal. Gotta plug in my phone. Try to click a little bit. So let's go ahead and update the code here. Put that in. I'm going to go ahead and copy the header as well. Let me go ahead and run verify. And you can see that the life cycle is now a little different. Read light intensity cannot be overloaded. What does that mean? What it means is that I have this function twice because I did not update it in the peripheral thing here. So I don't need this anymore. And it didn't work anyway, so. Go ahead and verify. I'm going to see it's not going to verify completely. It is going to throw at least one problem. Yes. That is actually not the problem that I expected it to throw. So, this requires a little more work to get right. I'm going to have to refactor a lot of this at some point. So this is saying send. Let's go ahead and remove those. And then if step key else and if just need to handle nulls here, and then command right if value in step key else and if. And again, if there's nothing there, I don't want to send any data. And that failed. Why? Because Cyanobyte has no value key. Yeah, which makes sense. So we switch it out. Send's not going to work without a value. That should work. I'm going to do that. Okay. So now if you look over at this code, we're seeing it's doing write power on, write reset, and whatnot without any parameters, because the functions don't have parameters, because it's just sending a command. So now we go back to the demo code that we've written to capture this information. As you can see, light sensor, write continuous mode, this now fails because it does not expect a parameter. We put one in, we're going to get rid of that. Read light intensity should not change at all, because it's still going to be a 16-bit number. And it's going to compile, and let's go ahead and hope it runs. Alright, let's upload. Let's find our serial monitor over here. And it's going to do some writing. And if this all works, then we can go ahead and update. There you go, 10. Just like before, except now the code is completely auto-generated. And just go ahead and throw the flashlight up. And it's going up quite a bit. So that's fantastic. The whole thing seems to work. Now we can go ahead and update all of the other templates. Both with the new raw read, but also you want to make sure that the command write gets an update as well. Nice thing with this ESP32 is that I can support multiple things with a few other small operations. So so where's the original? So we're gonna put this one here. This value is that key. Now we do the registers here. This might be a little odd because well, here I'm using a function pointer, which kind of expects me to make it a register. So I'm going to have people figure out on their own how to handle something like this. register address must be something that should never happen. But what would not happen? What would be an odd number? Don't think I can send CC is kind of an odd duck. Because I can't just do some sort of null. So or can I? I don't know. Maybe I can. Maybe I can. Well, we'll see what that does. And let's move on to I2C. This doesn't need to do anything. Keep OS will. Paste in length. It doesn't seem right because where am I putting in the address of the register? I don't. So that shouldn't seem there. I don't put in. Well, I guess no. It's because I'm making a buffer. No, it just doesn't. This never worked. Maybe. No, that looks so normal. So Python. Python might be. A bit. Well, let's see what we do for reading. Just use the standard bus operations. Where did I put? Okay, get. Actually, a lot of this is wrong. I'm not updating the variables like I'm supposed to be doing. I'm gonna have to go back around again. So this is I2C, read from device address, this number of bytes. And here we have a key. Register will never be signed. And move that. That should be byte list. It might not work with SM bus.
Discover new music with powered KPX feedback for RG.
Maybe we get the docs up. Might have to be just read byte. Yeah, it looks like it. There's nothing else I can use. Let me just copy this stuff here. So now these work. I need to calculate bytes here. Key. Self bus read byte. And that'd be self dot device address. Read each byte one at a time from device. We don't need those. Let's go backwards and make sure these are correct. The key writing into. And this is definitely not going to be null. And in fact, I can't even, these shouldn't be returning anything. And we just have to hope it works, you know? That needs a semicolon. Yeah, this is kind of so I don't need to do that. ESP32 should be good. Arduino. Embedded C. These all need brakes. And then cubos. Micro Python. Raspberry Pi. And now we gotta do a doc, data sheet, CMSys, what's the other one? I2C device. Now we have to update our validator. Update our code gen tool. Things here. And hopefully that's all we need to do. And then just do test, discover, test. We changed some MicroPython stuff. We might have. We also will have to update the doc. So let's doc really quick. Based on the home page, we're going to do BH1750FVI light sensor. Just do all the MicroPython stuff. Unit tests. Yeah. Now we can take a look at the diff. So I had to update. This updates. Yes. Setting that support. Setting that support. Just a bunch of stuff there. Adding those peripherals in. Adding validate support. Add these nice writes. This nice read. For Arduino. Here's CM Assist. We have all the size is kind of odd, but I think it's okay. There's LaTeX. So it only needs the write. It doesn't need any other data. It's just passing writes. Here's the UX16. And just redo a read, and this should be fine. This is ESP. We already tested this. We know this works. Here's a switchy device. Here's CubeOS. Okay, it's not requesting anything there. And then we have our read late intensity, and again, just updating that variable. Here's some markdown. Speaking of that, let me quickly go here. We want to make sure that gets updated in our code gen and pushed to the website. And it's here. I can't. This MicroPython. Yeah, we got to update the byte list. That was incorrect. There we go. Here it's only using self. That's the only thing you need to go ahead and do until you get down to late intensity. Set it up. Read in. We just start adding things to it. Again, we gotta fix all the byte lists. And your Raspberry Pi. Once more, we have these setters without any parameters. And down here, we get the thing. We read a byte to our datum. We logical OR it, and we return light intensity. So just add BH1750FVI light sensor peripheral. And a raw read command and other necessary changes. Fixes. Back to our issues. 184.
wish this gig wasn't booked after such a fun festival. Block party was much too much fun.
Alright, let's let that simmer for a bit. I might want to tackle this at some point soon. Look up, which ends up being another code function, which is like a when. Basically, it's a dictionary essentially. To translate from a binary thing into some sort of more meaningful value. In this case, also I need to do a field getter, sort of like I'm doing with registers. So get some binary value in, like 1, but that's actually not corresponds to something else, and this I want this when. Anyway, that's not for today, it's next time. Then I want to look at some other languages, the programming languages. I have Python, I have C, I have Arduino C, but JavaScript has some embedded stuff apparently. Rust has some stuff as well, and I think it'd be good to have some of those things incorporated as well, just to demonstrate the feasible power of this platform. This failed. So let's find out why. Call over the let's go to line 89. Yeah, these lines are a bit too long, unfortunately. So let's go to BH1750.YAML. So that's those 3 things, and then on line 23, it says it's not an enum. This is the Raspberry Pi? Yeah. Okay. For extended libraries. Nope, I don't want to do that. I wanted to go and I squared C as another option. This is pi dot ginger 2. And then I gotta look up the field enum or I squared or how do I I squared C dot address is iterable. Now IQC address is not string. MicroPython's unhappy.
the stars of the darkest night. Or the diamonds from the deepest ocean. I could say
No.
yours. Well, that's all I wish you know. But I might be gone alone.
And data sheet.
It's only this I'm asking. Is this all I can say? Make your time more.
CubeOS.
Well, I care, you ask me. It only brings me sorrow. For the same thing I want to have you. But I got a letter on the lonesome day. It was from a sheep that said, I don't know when I'll be coming back. It depends on how.
Okay.
If you, my love, must think that, but I'm sure your mind is wrong. And I'm sure your heart
And here I'm importing enum, right? No, I'm not.
with the country away. Take heed of West. Take heed of the stormy weather. Yes, there's something to say about Spanish boots
Scriptsy.address. Well, I don't know why I'm doing it there. Yes. Now you got the fixes to Raspberry Pi, Linton, which has a bunch of downstream effects. can watch this all goes through. One thing, source code is happy. Alright. Get more water. Alright, one thing, auto-generated files looks happy. Sample code gen passed, just got to update the code, and the pull request will pass, and then we merge it in, and there you go. That's how you build a peripheral in Cyanobyte for the BH1750. Took a bit longer than I wanted, but now it's going to work perfectly forever. Yeah. There's a few other things. Thing as I said before, the SP32 is also hooked up to a temperature sensor. So I'm reading the temperature from. Again, you know, it's some random code I found online that I've been using. And this is the code. I don't. This came from this person who forked it from another library and whatnot. But it'd be great just to have, like, this is the canonical. See, it's got, you know, this is not necessarily the best written code ever, and that's okay. But if you're going to spend a lot of time writing code, you might as well put it in your main code instead of having to work through all these random device issues. And of course, standardization is also kind of wonky at times. This has a get error function, which is built into this library as some custom thing with errors, and that's cool. But this light sensor does not have the same thing. Well, it didn't either in the past either. So now you're creating these inconsistent APIs. But what if you really wanted to have this nice error functionality in your device libraries? You could just write a single peripheral template, and everything will just be consistent API. So, this must pass, right? Now it's going to happen. And merged. Down to 18. That's doing pretty good. Pretty good place with this whole stuff. Close that window. Now I want to tackle this next. There's some interesting things here. At least in terms of the code that was written, there's some interesting ideas. Like this caches all the calibration registers at the start. I like that. That's not something I'm doing. Where do those variables go? They go in this thing over here. I don't like the names. I don't like that these registers just arbitrary magical numbers and constants. I like these comments. Those can go into the YAML file. I don't know, you don't need to do it. This also does all the calculations right at the start, so you don't have to continually run the computations. Cyanobyte does not currently have a way of using any sort of module level variables. So that's not to say you couldn't, right? So something to tackle next time. Until then, I'm gonna sign out and stream.